Hiya, it's Mr. Baker here. Today we're going to be looking at velocity time graphs. Okay, so today we're going to be looking at velocity time graphs. I'm going to be asking this question: can we find the distance something travels from a velocity time graph? And here, just as a little reminder, I've got a picture that's representing velocity. So we've got something that's moving, something's got a speed, and it's also got a direction. That's what this arrow is showing. So just remember that the difference between speed and velocity is the speed is how fast something's going, and velocity is how fast something's going in a certain direction. Okay, so we've looked at velocity time graphs in another lesson before this. And from velocity time graphs, we've related them to distance time graphs. We said in the distance time graph you can find the distance, and from the distance time graph you can also find the speed, and you can see whether something is accelerating or decelerating, or it's stationary, or it's going forwards, or it's going backwards. So you can tell quite a lot from a distance time graph. A velocity time graph, you can see how fast something's going. You can also see if something's accelerating or decelerating, and you can also find out what that acceleration is if you take the gradient. But we haven't looked so far at how you can find the distance from a velocity time graph, and that's one of the main things we're going to be looking at today. So let's just think about this little problem, and maybe you can pause it after this and have a go at this as well and then see the answer. But imagine that you are travelling in a car at an average speed of 30 kilometers an hour, and it takes you 3 hours and 33 minutes to get from your house to your nan's house in your car here. Look, that's the car you drive. How far is the journey that you drive? So to answer this, what I'd like you to have a little go at is to draw a velocity time graph to show this. Imagine that your car starts immediately at 30 kilometers an hour. There's no acceleration, you just go and you're at 30 kilometers an hour, and also you stop immediately. When you get to your nan's house, you just go and you just stop. There's no accelerating or decelerating anywhere in your journey. So see if you can draw that graph, maybe just sketch that graph. We're drawing a velocity time graph. Okay, so maybe just pause it, see if you can just sketch that, and then we'll have a look at it next. Okay, have you done that? Right, well, let's have a look then. Okay, so this is a velocity time graph. We've got velocity on the y-axis, and the velocity we've said is in kilometers an hour. So we can have any distance divided by any time to show a speed, can't we? So it could be meters per second or miles an hour, but we've chosen here to use kilometers per hour. And then we've got time on our x-axis, and we're measuring time in hours this time. We could measure time in seconds or milliseconds or whatever. So that is what your graph should look like. We said there's no accelerating, so you're just straight in at 30 kilometers an hour, and you're traveling, we said, for 3 hours and 33 minutes, which is 3.55 hours, and that's where you would stop. So you're moving with a steady velocity. We can tell that because the velocity is not going up or down, it's just staying the same, it's staying at 30. And so what we can do is we can find the distance. And the reason we can find the distance is if you can remember to the equation for speed, speed equals distance divided by time. If you rearrange that, then you would get distance equals speed times time. So if I'm going at 30 kilometers an hour for 3.55 hours, I would multiply 30 times 3.55, and I would find the distance that I've travelled. And that just happens to also map out this rectangle here, this area. So 30 times 3.5 is the total distance travelled. It's also the area that's under this graph, and that happens to be 106.5 kilometres in this case. So you've travelled 106.5 kilometres to see your nan, which is lovely. It's taken you 3 hours and 33 minutes, but the main thing from this is that we can find the distance from a velocity time graph if we look at the area underneath the graph. Okay, so that's what really we're taking from this. The area underneath the graph tells us the distance you've travelled on a velocity time graph. Okay, so really important point. Area under the graph equals the total distance travelled. So from a velocity time graph, that's what we have found out. But we didn't have any acceleration or deceleration in our previous problem. What happens if you're just accelerating? So here I know I'm accelerating because I'm increasing in velocity, I'm increasing in speed all the way along this time. So if I'm increasing in speed or increasing in velocity, then I must be accelerating, I'm getting faster, which is what acceleration is. We've just said that the area underneath a graph equals the distance. So in this case here, I'm moving with a steadily increasing velocity, which means I'm accelerating. So I can find out a couple of things from this graph, can't I? I can find out that the acceleration is the gradient. So the gradient of a velocity time graph tells us the acceleration. So that's one thing I can find out. And I do that by looking at the change in the y-axis divided by the change in the x-axis. Another thing I can find out though, if I'm using, it's just got a steadily increasing velocity like this, so accelerating, is that the area under the graph, we've just said, equals the total distance travelled. So this time it's not going to be the final velocity times by the final time, because my velocity has changed all the way. And I'm sure you already know how to work out the area underneath this. It's the area of a triangle, and the area of a triangle equals half times time times the final velocity. It's half times the base times the height, isn't it, to find out the area of a triangle. So here it's a half times the time times the final velocity. And that's actually the same as finding the average velocity and timesing that by time. So the average velocity would be somewhere over here, wouldn't it, in the middle? And actually that rectangle, if I mapped out a rectangle that was the average velocity times the time, that would be exactly the same. Okay, so that's pretty much it for this lesson. So there's basically 5 questions here that I'd like you to have a little go at, all based on this graph. So just read through the questions and then pause the video and see if you can do those questions, and I'll go through those with you in a second. Okay, have you paused the video? Okay, so let's go through these together then. So number 1, what is the acceleration during the first 20 seconds? So in the first 20 seconds, the object has gone from 0 meters per second to 10 meters per second. So 10 divided by 20, the gradient there is going to be 0.5 meters per second squared. How far is the object from the start after 20 seconds? So how far is it away from the start? So we can do that by working out this area of this triangle. So half times base, half times 20 is 10, times height, the height is 10, so half times 20, 10 times 10, that's 100 meters. What is the average acceleration during the first 40 seconds? So the average acceleration, what we need to do for the first 40 seconds is basically we look at what that line, if we drew a line sort of from there to there, what would the gradient of that line be? So it'd be 10 divided by 40. 10 divided by 40 is same as 1 divided by 4, so 0.25 meters per second squared. When was the object travelling the fastest? So this isn't a distance time graph, remember, it's a velocity time graph, so we can literally just read it off. So at 60 seconds it was travelling at 40 meters per second, and that's when it was travelling the fastest because that's at the highest point. And then how far has the object travelled in total? So we'd work out each of these little sections, and if you do that, then you would get to 1,600 meters. So hopefully you have done that. Well done. And that's pretty much it for today. So these are the things that you should be able to do from our lesson on velocity time graphs today. You should be able to identify the feature of a velocity time graph that represents the acceleration and the distance travelled, and you should be able to analyse different sections of a velocity time graph and calculate the distance travelled for one section of the motion, and actually that last question you did it for all of the sections. So well done on that lesson. That's it for now. I've been Mr. Baker, and I will see you next time. Thank you.